Hey guys, welcome back. Well, not welcome back, but good morning, good afternoon, good evening, and good night, whenever you're watching this. We're going to go through this quick problem and show you a composition of translations here. So here's our problem. You write a computer animation program to help young children learn the alphabet. The program draws a letter, erases the letter, and makes it reappear in a new location 2 times. The program uses the following compositions of translations to move the letter. So what are we given? We're given 2 directions, 1 and 2, for translations. And remember what a translation is it takes some kind of object and it moves it in space and time, or in this case just space, to another location. And that's what we're talking about, shifting something here. In this case, it does a double shift. So, or a slide is what some people do call it. So what do we have to work with? Suppose the program makes the letter N by connecting the points 1, 0, 1, 2, 3, 0, and 3, 2. What points does the program connect to make the last N? Well, let's take a look at the process. We have 2 directions and we have a set of points. Well, pretty straightforward, I hope. Let's see if we get it. So, the first translation that we're going to do is like case 1, and the directions are quite simple. They say, here's the horizontal part of the coordinate, here's the vertical part of the coordinate, and we're going to translate that. We're going to slide it, translate it, slide it, translate it, slide it, translate it, slide it, over, and using this direction. We're going to take what was ever in the horizontal position and we're going to move it to the right 2 places. Then we're going to take what's ever in the y and we're going to shift it up 5 places. And what we get is just that basic combination of things, and we can work it out. So let's take our points here, and we'll start with red. How about I label this one A, and here's A. A says that I start with 1, 0. So the translation of that would be 1 plus 2, 0 plus 5. And that leaves us with a coordinate point that's been translated to what? 3, 5. Yeah. So basically, this is the pre-image, right? And this is the image. So let's use a different color to do the next one. We'll use hot pink or fuchsia or whatever it is. So here's B, whoop, and B says we start at 1, 2. So I'm pretty sure you caught on by now that all we're going to do is be doing substitutions, right? So 1 plus 2, and then 2 plus 5. That's going to give us 3, 7. And let's use a different color. Let's use this color here, and we'll do that C, and here's C. And we take the coordinate 3, 0. We translate that in space to what? Well, now we take 3 plus 2, comma 0 plus 5, and we get out da 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 da. And let's get the last one. Let's do that in blue. So we'll have D here, and that's here. So the first set of translations looks like we've completed pretty well. Doesn't look too bad, right, guys? Can you tell me? Yeah? No? Sure? All right. So we've just finished the first set of translations, and now we're going to take these points here and use those to go through the second set of directions here. And the second translation, because we had to go through one and then the other, which is a composition. So we're going to take each one of those points and we're going to put them into the second translation, and that indicates that we take X and Y again. Remember, we're talking about a horizontal, right? Something that moves like this right here, see it? And then something that moves like that, right? Okay. So we're taking that shift And this time we're going to take the horizontal distance and subtract 10, and we're going to take the vertical distance and we're going to add 1 to it. So I'll use the same color code that we used before, and here's A. And A is now 3 comma 5, right? Because we're using the image now, which is now the pre-image to the new image that we're going to be making. And we translate that across space here in the two-dimensional realm. We're going to say 3 minus 10 comma 5 plus 1, and we get negative 7 comma 6. The next one was in fuchsia or something, whatever, B, and that was 3 comma 7. So we translate that. That's 3 minus 10, and that's 7 plus 1, and that'll give us negative 7 and 8. So it's really not too bad, right? Translations. So C, we have 5, 5. All right, and that's going to be 5 minus what? 10, whoop, and what? 5 plus 1, whoop, and then we get what? Negative 5 comma 6. And the last one we did in blue, so we'll finish off in blue here, and that will be 5 comma 7, and that's translated again 5 minus 10 and 7 plus 1, and that gives us negative 5 comma 8. So now all we have to do is take our final set, which is this new image that we've generated here, and answer the question. It says, what points does the program connect to make the last n? Well, how should we write it out? Well, how about we make it easy? The program connects the points negative 7, 6, negative 7, 8, negative 5, 6, and negative 5, 8 to make the new n. How about that? Is that okay? And let's just box our answer, and I'll look. Oh, I can't move it back and forth there. Okay, that's good enough. But seriously, we can just box our answer like that, and that's it. Hope that helped looking at compositions of translations. See you soon. Let me know if it helped. Bye.